Okay, let's get continue. In order to understand nonlinearity, maybe we should first understand linearity in causal effect. So linearity means a unit of treatment will correspond to a unit of outcome. So in my case, that is, if I have my grandpa take a dose of vaccine, then I should observe some reliefs from his situation. And say if I take two doses of vaccine, then I should observe something getting better. And if I have my grandpa take totally three doses of vaccine, then maybe my grandpa can already recover from the pandemic. So that is linearity. But in contrast of linearity, nonlinearity means there might exist a threshold, a medical threshold. That is, um, if the threshold requiring a intensity of maybe three doses of vaccine, then so if my treatment only take one or two doses of vaccine, then there is not any signal of getting better of my grandfather. So that is the tricky point of nonlinearity. If we apply this to the previous example, which is we only focus on the direct effect, then the treatment will not be significant. If we only focus on indirect effect, then the treatment didn't work neither. The virus can only be eliminated if we put in together the treatment, because only when we put in together treatment can we reach the intensity required by the stressor. Okay, so to fix this problem, uh, let's see the following picture. Here I draw the levels of enzyme uh, varying with the weight of our treatment process. And the curve here represented the normal level of the enzyme. And T0 here means we are at the time point, that is the initial time point before we starting the treatment. So in order to test the indirect effect, we we will resort to some kind of elixir to raise the level of enzyme. So we got a curve like this. And here, the capital T means we specify another time point that is after treatment. Okay, so notice that here we are in a situation uh, that is our grandpa didn't take the vaccine treatment. So without the help of the vaccine, without the direct effect, the indirect effect of the enzyme just fails to reach that threshold. Notice that I didn't say the vaccine didn't work in our body. In fact, sorry, I didn't say the enzyme didn't work in our body, because there might be some chemical reaction happen. Uh, but this is not about the enzymes for. This is about the nonlinearity setting um, shows that it just couldn't reach the threshold, but the enzyme did play some physiological roles in our body. Okay, so if we put this into the formula, a simple formula of the NIE, the natural indirect effect, and here the capital Y means the outcome. So YT means the outcome after the treatment. So YT0 means the outcome before the treatment. And to calculate the difference between this treatment, we do a subtraction. And since both of the treatments the effects are lower than the threshold, then we assign 0 to the formula. And 0 minus 0 will equals to 0. And this is how we have already get from the previous example, right? And now let's turn to another setting, the counterfactual thinking. And before we go to that, I will remind you to this simple to T0 and capital T. I noticed that I specified this too simple because I want you to um, notice that when we are talking about the counterfactual thinking, we are just like saying something like turn back the clock, and we looking back retrospectively. So here's the reason why in this picture we will start from the curve capital T, because in this setting we suppose my grandpa did take the vaccine treatment. So with the effects of the vaccine and the enzyme boosted by the vaccine, they working together, they reach the intensity of the stressor and finally wipe out the virus. So we got a curve definitely above, on top of the stressor. Okay, so it goes like this. And standing at this point after treatment, let's looking retrospectively and ask a counterfactual question. That is, what should have happened if my grandpa hadn't take a vaccine treatment? So we're looking back and we go into the initial time point t0, which is as we have already seen in the left picture. So the whole picture goes like this. And this direction compared to this one, the left side is quite significant because in this picture, you see the range here cover the boundary of the threshold. And if we put it into the calculation, and here I will call it the inverse version of the NIE, and we have the formula goes like this. And you see here y capital T because now the curve is exceeding the threshold. So we assign a 1 here. Okay, so we subtract 1 from 0, we will get -1. All right, this is quite significant compared to a 0 version of the NIE. Okay, uh, let's get closer. Um, initially when we think of calculating total causative fat, we think of something like we have the direct fat and we plus the indirect fat, which is simply combine the contribution, which is simply combine the advantages. And when we face some problems such as nonlinearity, that motivates us to think of a inverse indirect fat. So what does this inverse version mean? Here, I would like to say you can think of this like the potential loss, just as the picture shown like this green shadow range. If you're looking back and see uh, what is your loss if you don't take this treatment. Okay, so keeping this in mind, what we can do is we can make a big change to this general principle. This is what we call the additive principle of the calculation of total causative fat. Instead, we have a subtraction version, which is like this. You see, instead of plus a indirect fat, we subtract the potential loss brought by the indirect fats from the direct fat. So to give you an example, notice that we have already calculated direct fat or the NCE. Uh, uh, yes, NCE equals to 0, and the inverse indirect fat equals to -1. So we subtract -1 from 0 equals to 1. Okay, so this should be the true version of the total causative fat. The total causative fat is not 0, but it's 1. Okay, here is our subtraction principle, and you might know we get this by the counterfactual thinking. And this is another point that Professor Poor had highlighted in the book of Why in the last chapter. And for this one, personally, I would like to say the magic of this principle, this subtraction version, is that we use intervention based on a counterfactual idea. Okay, that's it. So, yet I haven't told too much about the causal diagrams. Um, uh, but I think maybe this is another point I want to share you in this presentation, because I just want to show you how we can use the causal diagrams to encapsulate these several situations, different types of causative effects. We can do it by simply using the causal diagrams, and specifically by use the do calculator if you have heard of it. Okay. Um, we will talk about this in the next video and to end this episode.